Dobrý deň, vážené dámy, vážení páni. Moje meno je Štefan Vaľo, som zo Slovenska. Nakoľko neovládam anglický jazyk, moje skúsenosti, merania a pozorovania z prírody za mňa bude prezentovať kolega pán Roman Gajdoš.
Good morning, ladies and gentlemen. My colleague, Štefan Vaľo, has just greeted you in Slovak language. As he doesn't speak English, I will present on his behalf our project based on research, measurement, and on-spot evaluation of the situation in the forest. So, how forest soil compression impacts climate change? Just as any other person living on this planet, I also see the rapid changes of climate. I have been living in fear as the media keep on feeding us with information about growing temperatures and the accompanying extreme weather events that we should expect, and they tell us that the situation will get only worse. Yet, standing by the almost empty river Úh in Slovakia, back in the summer of 2009, I asked myself the first vital question. And my first question was, why is there no water in this river? And the answer came to me almost immediately. Because it is in the oceans, very simple answer. Then I asked myself, why does the water flow away so quickly? And the answer arrived some 10 minutes later, when I thought back to my logging roads building career. I realized that I have only seen the rainwater flowing on the forest roads, on the logging tracks, and along the compressed surfaces left by heavy machinery. On the other hand, the rainfall which fell on an undisturbed forest soil was absorbed immediately, even in the case of heavy rains. Having realized that, I started asking other questions and kept looking for the answers. Based on the decades of my experience, intensive observations and measurements, I have come to the following conclusion. It is not the climate changes that are to blame for the drying out of soil, lowering of rivers and groundwater levels. Rather, the real culprits are the three phenomena which keep on spreading quickly on the planet. The first one, the compressed surfaces. The second one, man-made slopes. And the third one, draining ditches in the lowlands. I'm going to go into details to explain better. Look at the compressed surfaces left by heavy machinery in the forest. Or man-made slopes. Can you see the tiny holes, the capillaries that let the water flow very quickly out from the forest? And the draining ditches in the lowlands. All these phenomena contribute to the draining of lands, thanks to which the sun heats up the soil, which consequently heats up the atmosphere. These three phenomena influence climate change dramatically. All the evidence you can see in the documentary film I realized. It is based on my research and evidence gathered in the forests. Ladies and gentlemen, my aim at this forum is to draw attention to this unregarded phenomenon as it inevitably leads to catastrophes. Appeal to those who can and who have the power to pass relevant water and soil protection legislation and to create efficient control mechanisms without which the above-mentioned laws would be useless. I wish to share my experience with you. It is important, as we are talking about saving our planet. We are talking about water. At the end, let us show you part of our documentary film offering the results of a pilot project I implemented. You will see how a series of simple measures solve problems caused by the phenomena I identified. My solutions provide enough water, both on the surface and under the ground, there where water is needed, to feed wells, reservoirs of drinking water, sources and roots of vegetation. River levels will rise not only in the lowlands. If I had to sum up my project, the efficiency of which, by the way, was already proven by independent experts from the Slovak Academy of Sciences, I would simply state: let the water soak into the ground there where it falls. Don't let it flow down quickly to oceans. Thank you for your attention, and now we can play the document.
And sustainable. I tested and tried the proposed interventions in 2011 in 2 Eastern Slovak locations. I focused on defunct forwarding paths, ruts carved by heavy machinery, and compacted soil, and I decided to decompact them transversely with excavators along the entire length and width from top to bottom. This way, the pits dug out by the excavator would retain the rainwater. When the pits were freshly dug, the rainwater would take even longer to seep in. It means that the water created channels, new capillaries, and infiltrated the ground to reach the plant roots, springs, and groundwater. When I returned in spring 2013 to observe the decompacted soil, I found water in 15% of the pits at most. In the other pits, the soil took in the water immediately, much like an intact forest soil. If there were man-made slopes less than 2 meters high over the compacted soil areas, we ripped them to a depth of approximately 1 meter, so the water oozing from the capillaries could gradually infiltrate the decompacted soil in the slope and the dugout pits. The Slovak Academy of Sciences put the capability of decompacted soil to absorb water effectively to the test. The experiment was conducted on an eroded road formerly used for transporting timber. The scientists simulated rainfall with the intensity of 100 millimeters for 3 hours. The measurements showed that whilst the compacted earth hardly absorbed any water, the decompacted path retained 100%. How to resolve issues relating to man-made slopes. Man-made slopes over forest firefighting paths and haul roads that serve to truck the timber out of the forest can be treated in the following way. We decompact the soil 1 meter in width and approximately 2 to 4 meters in depth along the contour line, approximately 5 to 20 meters over the man-made slope. The water discharged from the disrupted capillaries will seep in the loosened soil and gently reach capillaries in deeper soil layers. How to resolve issues relating to lowland drainage canals. I propose small concrete barriers with an opening to be installed in drainage canals that allow the regulation of water levels in canals and, by extension, groundwater levels. I put this technology in practice in 2010. After 2 years, these measures proved their validity and functionality. These shots were taken in the dry summer season of 2012. The water level in the canal and the well 100 meters away match. which means the canal is integral in maintaining groundwater levels and replenishes the wells. While the canal is empty, the water level in the well 70 meters away is 24 centimeters higher. The dried up canal gradually drains the water from the well until both water levels even out. I took a number of measurements in different places. All of them proved that there was a correlation between the water level in canals, wells, and groundwater. Wherever the canals were regulated well and managed to retain water, the wells nearby were not short on water. Their water levels seemed stable. However, canals without water are detrimental to the groundwater system because they slowly drain it. Simple solutions are often most effective. Paradoxically, they are often the most difficult to gain public recognition. We tend to underrate ideas, which are right under our noses and they align with nature. Instead, we are drawn to complicated constructions and to speculations about too much rainfall or global warming, which we supposedly cannot influence. I am convinced that just as we can harm the nature on one hand, we can help it on the other. We can carry out thousands of small and financially undemanding interventions with immense final effect. Let us retain water where it falls. Let us stop unchecked water drainage and landmass desiccation. Reasonable and simple solutions are innate to nature, and they can minimize disasters. Please give them a chance. I did, and you can too.
So thank you very much, and if you are interested in the whole document, we are ready to distribute it and we are ready to discuss the topic right now. Thank you.